Okay, theoretical versus experimental. Experimental versus theoretical. Now, you might be sitting there going like, what vocabulary word is she using? Trust. We've actually already used theoretical and experimental as a conversation. I've used those vocabulary words, but today we're going to write down the definitions because you're going to need it for your homework tonight. Okay? So let's define first theoretical, because it's actually the first one we did. Theoretical probability. Theoretical probability is probability based on math. Okay? Probability based on math. What? Are we in math? Isn't everything based on math? Yes and no. So, theoretical probability is based on math. You've been doing a bunch of For example, what is the probability of landing on heads when I flip a coin?
What happened?
Okay, you see how you knew that? Did you have to flip it? No, you knew that because it's based on math. There are two sides of a coin. One side is heads. So therefore, it's 50%. So probability of landing on heads is 1/2 or 50%. How do you know? Because you know the math, right? There's two sides. One of them is heads. So therefore, the probability of heads is 1/2. Did you flip a coin? No. So that's what theoretical is. It's just based on math. Okay, draw the most perfect circle in the world. And then divide it into fourths. Okay. I'm going to write B for blue. I'm going to do 3 B's for blue. And one section will be red. Wow. Green, because I wrote G. Whatever. Wow. I'm losing it. I need a donut. Oh, there it is. Okay. I do. You should all chip in to buy me a vacation to Hawaii. It was just kidding. I'm kidding. I just recorded myself saying that. I don't know. So, what's the probability of landing on blue with this spinner? 75%. What was the fraction? 3/4. Why is it 3/4? Because there's 4 sections and 3 of them are blue, right? Did we do any spinning? No. But yet you have an answer. You can tell me that the probability of blue is 3/4. Why? Because you did the math, and that's called theoretical. Okay, what's the probability of green? Or red? What is it? What's the fraction? 1/4. What's the percent?
10%.
No. Guess what? My answer does not have a 1 or a 4 in it.
0.
Krista?
25%.
25%. Look, it doesn't have a 1 and it doesn't have a 4. 99% of the time, these numbers in your fractions don't have percents. Don't have them in the percent or decimal. All right. So, yes, and it has to equal 100. Yes. Called being in the same class together. So, that's theoretical. Miss Lamelli has a 1 in 5 billion chance of winning the lottery. Okay? That's the odds. 1 in no, it's not going to happen. All right, here's experimental. Experimental probability. Experimental probability. What do you think experimental probability is? Theoretical is just doing the math. What do you think experimental is? Experimental. Yes? How to find the answer? Well, experimental, kind of like science. When you do an experiment, what are you doing?
Testing it.
You're testing it, right? You're actually doing it, right? Well, back in the day. So experimental is you're actually spinning it. You're collecting data. So is probability, so it's still probability, but this one, it's based on results. Data. It's based on results, data. Remember yesterday how I had you guys spin the spinner 10 times? And did it match our answers with theoretical? You know how we were only supposed to land on yellow one time? And did we land on yellow one time? No. Why? Because you did an experiment and it didn't match the math. And that's fine. Because when you flip a coin, do you always land 50% on heads and 50% on tails? No. Sometimes you end up with like 2 heads and 1 tail, or whatever it is. Yes? Yeah. By the door. Okay, experimental probability. You toss a coin 50 times. Whatever you get as a result, that's experimental. Because you like literally did it. You flipped it 50 times and you took tally. Remember yesterday? You spun for a, what did I put, all right, spin the spinner 10 times, it's 50. Okay, so here are 2 examples of experimental probability. You toss a coin 50 times. You spin the spinner 10 times. Like, you are doing the actual whatever it is. Tossing, spinning, whatever it is. If you do it and you keep tally, remember yesterday how we kept tally? That's called experimental. Like you experiment, you test it. I like that word that you guys, Jason, that you use, like you're testing it. On your homework tonight, which I'm not handing out right now, but I'm recording it, so it's going to be on the YouTube. Write theoretical or experimental to describe the probabilities for each of the following situations. So, the chance of getting tails when flipping a coin is 1/2. The chances of flipping. Did it say that you're going to flip it? No, it says, hey, you know that the chances of flipping is 1/2? So did we use math or did we experiment? Math. Because it just says the chances of getting tails when flipping a coin is 1/2. Is there like a verb that says do it? No. So this would be theoretical. Okay? Now let's look at B. I flipped a coin 8 times and I got heads 6 times. So the probability is 6/8. Did they experiment? Did you experiment or did you just do the math? Yes. Experiment. I flipped. That verb is like, oh, I did something. So this would be experimental. Does that make sense? Okay. So theoretical and experimental. So you're going to read the next couple ones on your own. And you're going to figure out like, oh, wait, did something actually happen? Or are they just telling me like, yeah, if you flip it, you get 1/2? Or did we actually flip it? Okay? So for these, you're just going to tell me theoretical or experimental. We're good? We're okay with that? Okay. Now we're going to go into our textbook. And we're going to be on section 1, 2, 3. So let's find your textbook 1, 2, 3, please. How can I change the chances of you not going to nutrition on time. What? Did I say that out loud? Oops.